In this video, we will demonstrate the Bernoulli's principle in our Ansys software. We will use the Venturi meter tube for our experiment. As we all know that according to the Bernoulli's principle, the pressure of inlet will be high and also the pressure of outlet will be high. But in the narrow area, in this area, this is called throat of Venturi tube. Here the velocity will be high and the pressure will be low. You can see this picture. So in our today's video we will try to visualize this. At first, open your workbench, choose it fluid flow, select the analysis type 2D, but you can also work with 3D if your model is a 3D model. Now I will import my geometry. So now to show you, I will double click on geometry. Here you can see, click on generate. This is our geometry. Now I will make it fluid. Okay. Now close design modeler. Double click on mesh. So this is our mesh window. Let's make a general mesh. You can see the mesh size and quality, but we will change the size. Now select here inlet and outlet, type, change it to number of division. I will make it 50. Okay. Now again another sizing. Hold the control key and select your wall area. Ten is number of division. Make it 50. Okay. Now click face meshing. Select here. Click on apply. Now click here. Generate mesh. Now you can see the difference. A well-oriented mesh. Now I need to define our inlet, outlet and wall. Click here. Rename it as inlet, as this is our inlet part and this is our outlet. And this area is our wall. Again hold the control key and select this. Rename it as walls. Okay. Now select the face. Okay, you can see this is our inlet, this is our outlet. Close meshing. Update your mesh. Okay, now double click on setup. Here click the double precision in solver option and change it to 4. Click on start. Click on OK. You can check mesh. This is our mesh quality. Now I need to define the model. Click on viscous. Click on OK. Now I need to select our fluid. By default the fluid is air, but I need liquid. So click on Fluent database. You can select any fluid. Click on copy. Close. Now select water. Select here change. Click on close. Okay. You can see this is our new fluid, water, and you can keep it as usual, solid aluminum body. Pipe is aluminum. Now click on cell zone. Click here fluid domain. Click here edit. Change the material name liquid. Click on apply. Close. Now I can delete this fluid. Okay, you can see only one fluid, liquid. Click on the boundary condition. Boundaries. Inlet, this is velocity inlet, and the outlet, pressure outlet. You can also change it to pressure inlet. Give the inlet velocity of your fluid, any number. Okay. Keep your gas pressure 0. Now click on methods. You can keep it simple. Okay, double click on control. This is our solution controls. Click on residual, change it to 1e minus 6. Okay, change all the data. Okay, it will give you better result. Now click on initialization. You can keep it as hybrid. I will use standard initialization, compute from, inlet, initialize. Okay, our initialization is complete. You can see the blue sign indicates the inlet and red sign indicates the outlet. Now I need to double click on run calculation, set the number of iteration, thousands. Now click on calculate. Here you can see calculation process is going on. Okay, our calculation is complete. Click on OK. Here, right click, select new, line, type pressure line. I need to make it 150. Okay, another line, velocity, click on close. Here you can see pressure line, velocity line. Double click on contours. We want to see the pressure effect. Click on save or display. Okay. Here you can see the pressure. In the narrow area, the pressure is low, but in inlet and outlet, the pressure is high. Again, double click on contour. Velocity contour, contours of velocity. Fluid drumming, curves. Now you can see the velocity. It indicates that in the narrow area the velocity is high, and in the inlet and outlet area the velocity is low. As we said that according to the Bernoulli's principle, the pressure will be here low and velocity will be high. So you can see the red area indicates that the velocity is much higher than the inlet and outlet. Now you can plot a graph of your velocity and pressure. So take XY plot. Now pressure graph. Okay. Click on pressure line. Direction vector. Okay. Close. Here you can see this is our pressure line. If you change the length of your object, then also the pressure curve will be changed. But as I doing it for just demonstration purpose, so I will not change it. Again, double click on velocity graph, change it to velocity line. Okay, you can see the velocity curve. Now I can close. Double click on result. Now you can take velocity control, variable velocity. Okay, click on apply. So you can see the pressure. Make it velocity variable. Change it to H1. Okay. Here you can see the velocity control. Click on streamline. Start from inlet. Just make it 100. Apply. Now you can animate this result. Click here, animation, select the streamline. Here you can see the animation.